Good morning, pre-K. Happy Friday. Today is Friday, March 5th, 2021. We have been learning about Dr. Seuss all week, and I hope you've been having so much fun. Now we're going to get back to the water unit, and today I'm going to read a story called Things That Float and Things That Don't. And then afterwards, we're going to do a little experiment that you can do at home as well. Our world is covered with rivers, lakes, seas, and oceans. More than 2/3 of the surface of the earth is covered with water. So there's a lot of water we're surrounded by. Before there were planes, people traveled across oceans from one continent to the next, and they traveled and moved things over rivers and across lakes. A whole crowd of people could be on the boat, and it would still float. But if one of those people dropped a small pebble into the water, that pebble would sink quickly. Pebbles don't float, so boats float, but pebbles, which is like a little rock, do not float. You could have fun guessing which things float and which things don't. Fill your sink about halfway with water. Get a penny. A penny doesn't weigh much, but if you put it on the surface of the water, it falls right to the bottom. It doesn't float. Get an empty plastic soda bottle. Fill it about halfway with water. It's much heavier than a penny, but see what happens when you put it in the sink. It floats. So a penny goes right down to the bottom. Water bottle stays floating. Find things around the house, things that won't be damaged by water. Make a list of what you found. Next to each item on the list, write whether you think it will float. One by one, put each item in the sink. How often did you predict correctly? Which things float, which things don't? It's not just weight that determines whether something will float. It's also the object's size and shape. So this is what we're gonna do. It says get a piece of aluminum foil. Form it into a very loose ball. So you take the foil, but you don't crunch it, squeeze it. Just kind of like crunch it just a little bit, so it's a little bit open. And place it on the surface of the water. You will see that the aluminum foil floats. Now you take the aluminum foil and you squeeze it nice and tight. Place it on the surface of the water. Now it sinks. The aluminum foil weighs the same whether it's loose or tight. But the second ball takes up a lot less space. Its density, can you say density? Its density is its weight relative to the size, is much greater than the first ball. The density of the second ball is greater than the density of the water. So if it has more density, it's going to sink. What's the density of water? Have you ever filled a bucket with water and tried to lift it? Water is heavy. A cubic foot of water, enough water to fill a box 1 foot high, 1 foot wide, and 1 foot deep, weighs a bit more than 62 pounds. That's a lot. See him? Something that has a lower density than water, if it weighs less than 62 pounds per cubic feet. Something with a lower density than water is going to float. So the more density, it's going to sink. The less density, it's going to float. And it has nothing to do with how much it weighs. It could weigh the same thing. It says, do apples float? 1 cubic foot of apples weighs about 40 pounds. That's less than the density of water. So when you put an apple in there, it's going to float. Does a bar of soap float? 1 cubic foot of soap is about 50 pounds. That's less than the density of water, so the soap floats. Does clay float? 1 cubic foot of clay weighs about 100 pounds. The density of clay is much greater than the density of water, so a lump of clay is going to sink. Get some modeling clay. Place a lump on the clay of the surface of the water in your bath, and you'll see that it sinks. Now let's make it float. Now if you take the clay and you give it like a little dip inside, like you make it into like a boat, place the boat on the surface of the water and see, does it sink or does it float? The lump of clay and the boat made from it weigh the same. See that, because it's still the same size of clay. Let's see what he did to it. It says the boat takes up more space than the lump of clay because of its shape, and now the boat encloses air. So the density of the boat and the air is enclosed is now less than the density of the water. That's why it'll float. Now, with the clay boat in the water, take a look at the sides of the boat. The boat is not really floating on the water, it's floating in the water. So see how part of it is underneath the water? So it's not completely on top of the water. It's like halfway in there. So now they want you to put a few coins or marbles or pebbles in the boat. As the boat and its contents get heavier, more of the boat goes under the water. So the more stuff you put in, the deeper the boat is going to go in, but it's still going to be floating. As the clay boat sinks lower, it pushes water aside. That's what it called. It displaces water. The weight of the water the clay boat displaces equals the weight of the boat and its contents. So it's trying to even it out so this way it could stay floating above the water. Because of the shape of a boat, part of its contents is air. The boat will continue to float if the density of the boat and its contents is less than the density of the water. Steel is about 8 times as dense as water. A cube of solid steel would quickly sink, but the hulls of large boats are made of steel. Boats made of steel float because of their shape. So that's why. It's heavy, but it floats because of its shape. Now, get some ice cubes. Drop the ice cubes in the sink. They float. Why does ice float? Ice is water. Icebergs are huge, floating mountains of ice found in the colder parts of the world. Why do ice and icebergs float? You can find the answer in your freezer. This is full of a lot of different experiments we can try. Put some water in a paper cup. Make a mark on the side of the cup to show the level of the water. Now, put the cup in the freezer and wait until the water has completely turned to ice. The level of the ice is now higher. See, this is where the water was. Now it's frozen, and look, that's where it is. See how it went up? It says when water freezes, it expands. Ice weighs the same as water, but ice makes up more space. The density of ice is slightly less than the density of water. That's why it floats. Not all water is the same. Have you ever been to the beach? Was the beach at the edge of the ocean or was it on a lake? Ocean water and lake water are very different. Ocean water is salty. Lake water isn't. Ocean water is denser than lake water. Some things will float in an ocean but sink in a lake. So floating in an ocean will be easier sometimes compared to a lake. So it might be easier to swim in. You can prove the density of salt water is greater than the density of plain water. Get an empty plastic soda bottle with a cap. Fill the bottle about halfway with water. Mark the side of the bottle to show how much water is in the bottle. Now, add about a teaspoon of table salt to the water. Put the cap on the bottle and shake it up. If you check the level of the water, you'll probably see that it didn't change. What happened to the salt? This is another fun word. It dissolved. What was once plain water is now salt water. It takes up the same space, but there's more to it. If you checked, you'd find that it weighs more. The density of salt water is greater than the density of plain water. Of course, the saltier the water, the greater its density. So dissolved is like mixed in there. Different things have different densities. Even different kinds of water have different densities. That's why some things float and some things don't. So this story had some awesome experiments. So you can go back, to the reading and try out some stuff that they had in the book. But my favorite is doing a sink and float experiment. So I'm gonna show you, and I will send this paper in an email. You make predictions. You're like a scientist. Predictions is like a guess, but not a silly guess, a smart guess. And here is a bunch of different items that you can check to see if they sink or float. So your job is to find these items. We have a penny, a pencil, cotton ball, wooden stick, crayon, rubber band. So find all these objects if you can in your house. If not, you could pick different things, that's fine. And then here, it's a smiley face. It floats or it doesn't float. And you're gonna make a guess before you even do it. Try to make a prediction. Think about it. Say, do I think a penny will float? Yes or no? Do I think a pencil will float? Do I think a cotton ball? And then you try it. And afterwards, you say, oh, was I right? Was I wrong? It's okay to be wrong. It's just an educated guess. So I have here a little bin of water. I'm gonna put some blue food coloring in it just to make it a little fun. But you can just use regular water, that's fine. And we're gonna see if these things can float. Now remember, floating is based on the word that we learned today is density, okay? So it's all based on its density. It doesn't matter how much it weighs. What matters really is like the shape of it. I just wanted something to mix it with. You know what? I'll mix it with a popsicle stick. So it looks really cool. And I'm gonna move the camera so you guys can see a little better. Mixy, 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 mixy. Ooh, that looks nice. Okay, and I'm gonna move you guys so you can see it better. Okay, hold on. Can you see it better? Yes. Okay, so here's my little, and I'll bring it closer to you guys so you can see. So the first thing on our list says penny. So let's go, let's find a penny. Let's go, let's go, let's go. It's in the bottom of my bag. So now you make a guess. Do you think it's gonna sink? Do you think it's gonna float? So let's see, we make our guess. And now we're gonna find out. Did it float? Bring it closer. Is it floating? Where did it go? It's in the bottom. Oh no. So it sank. Okay. Then maybe I will try a pencil. Okay. Do we think it's gonna sink or do we think it's gonna float? Let's try. What's happening? Bring it closer. It's floating. Okay, so I don't want to do the whole experiment. I want you guys to do the rest. Remember that you can do the same objects on the list, or you could come up with your own objects. And remember to make your prediction, your smart guess first. Then you do the experiment, and then you say, have a conversation with mommy and daddy and say, oh, I was right, oh, I was wrong. Talk about density. Was the density more than the water? Was the density less? Okay, and that it doesn't matter about how much it weighs. Look at the shape of the object that sinks or floats and see how that affects it. So, thank you for joining me and learning about density today and things that sink and float. And I can't wait to get some pictures to see what kinds of objects you tried. I'll send this in an email in case you want to do this exact experiment, but you can do your own. All right? Thank you for joining me. Happy Friday. Bye-bye.